Up until now, we've been calculating gas laws with pressure, volume, and temperature only. Now we're going to include the amount of a gas in moles or grams. So an ideal gas is an imaginary gas that conforms to all of the assumptions of the kinetic molecular theory. The equation PV equals nRT is known as the ideal gas law, which includes pressure, volume, moles, the ideal gas constant, and temperature. The pressure can be in any of these 4 units. The volume must be in liters, so if it's not, you have to change it to liters. N must be in moles, so if it's not, you have to change it to moles. R could be one of the following constants below in the box, and T must be in Kelvin. So whatever your pressure unit is, you have to use a matching R unit below. So you can see this first one is 0.0821 corresponds with atmospheres, 8.31 corresponds with kilopascals, and 62.4 corresponds with millimeters of mercury. The pressure unit can change. For these calculations, make sure to choose the R that matches the unit of pressure given in the question. So, using the ideal gas law to find molar mass, the ideal gas law is PV equals nRT. When a problem gives pressure, volume, and temperature, we can calculate moles. And if they give you mass in grams of an unknown gas, we can use that mass and the number of moles to get the molar mass with the following equation. Molar mass is equal to grams divided by moles, or mm equals G over moles. Now, to derive, we can actually combine our ideal gas law equation and this equation that we just saw on the previous slide in this way, that if I rearrange it, moles is equal to grams divided by molar mass from the periodic table. And I can actually insert this, grams over molar mass, in place of N, and that's going to give me PV equals G over mmRT, and then I can move the mm to the left side by multiplying both sides by molar mass, and then I can get this. Molar mass times pressure times volume is equal to grams times R times T. So, essentially, we're going to use 2 equations. PV equals nRT, and then MMPV equals GRT. You'll be given these equations. Let's look at this first sample problem in our note packet. If 9.00 grams of an identified gas occupies a volume of 0.500 liters at 101 degrees Celsius and 0.970 atmospheres of pressure, what is the molar mass of the gas? These are our 2 possible equations. This is pressure, volume equals moles times R times temperature. This one is molar mass times pressure times volume equals grams times R times temperature. So since they gave us grams and they want molar mass, what is the molar mass, I want to use this second equation right here. So now that I know which equation I'm going to use, let me write it here. MM times P times V equals G times R times T. Eventually I will not put the dots, but for now, since we're new at this, so this value here is our grams, and this value over here is our volume. This is our temperature, but we have to add 273 to change it from Celsius to Kelvin. So plus 273. This is our pressure, and the question is, what is molar mass? And so I'll circle it to know that that's my X. So now I can plug in the values that I have in my equation below. Molar mass is my X times the pressure I was given was 0.970, and it is very important to note that that pressure is in atmospheres, which is going to tell us what value of R we're going to choose. So we're going to look for R, and since this is in atmospheres, that means I want to choose the R constant that's also in atmospheres, which is going to be this one right here. So we're going to use 0.0821 for R when we get there. So pressure is 0.970 atmospheres. My volume is 0.500 liters. It must be in liters, so that's good. Equals the grams that they gave me, which is 0.900 The R, remember, we have to look at our pressure. Our pressure is in atmospheres, so I'm going to choose the R that has atmospheres. So we're going to use 0.0821. And then the temperature is 101 plus 273, which is going to be 374. So now we can calculate our answer. And what we're going to do is we're going to type in, see how our X is on this side? We're going to start on the other side. We're going to do 0.90 times 0.0821 times 374, and then we're going to hit divided by 0.97 divided by 0.5. Calculator will do 0.900 times 0.0821 times 374 divided by 0.97 divided by 0.5, and that's going to equal 56.98. So our final answer is X equals 56.98. Since our answer is molar mass, the unit of that is grams per mole. And then if we had an element to compare it to, we could actually say what gas this is by comparing the mass of this gas that we solved for with the actual mass of another gas from the periodic table. Okay, here's another example problem. So remember, we are going to use one of two equations. It's going to depend on what do we have and what are we trying to find. So first, I'm going to go through the problem and I'm going to mark my givens and what I'm trying to find. When the temperature of a rigid hollow sphere containing this many liters of gas, so there's a volume, is held at, and then there's a temperature of 348 degrees Celsius, and we want to make sure that we convert that temperature to Kelvin, so we're going to add 273 to it. The pressure of the gas is 1.87 atmospheres, and this is going to be very important. It's going to tell us which R value to choose, and the question is how many moles? So N is moles, and that's what we're solving for in this problem. So notice that we have moles, and when you have moles, you want to use this first equation. If you see grams, you want to use this second equation. So we're going to use the PV equals nRT. So my equation is PV equals nRT. I'm going to go ahead and plug in the values that I've been given. The pressure is 1.87 atmospheres. The volume is 685 liters. It must be in liters, so we don't have to make a change there. We are looking for N, how many moles? So that's my X. Now, R has to have this unit here, and so we're going to go look at our reference chart and look for the R value. And the R we're going to use is with ATMs, which is going to be 0.0821. So this is 0.0821. And then our temperature is 348 plus 273, which is 621. Got to add these together to have my Kelvin temperature here, my temperature. So here we have P times V equals moles, which is what I want to find, times R times T. And now I can solve this in my calculator. Do not start on the side with the X. We'll start over here, 1.87 times 685. And now these guys with the X we get divided by. So we're going to divide by this, divide by this. So to type it into the calculator, we're going to type in these two values first, 1.87 times 685. And now I can come to the other side and I'll hit divided by 0.0821 divided by 621, and we're going to get 25.12. So our final answer is X equals 25.12, and remember we were solving for moles, so that is the answer in moles. Okay, next problem, we have to figure out which equation are we going to use. If we're given moles, we'll use this. If we're given grams, we'll use this. So, determine the volume. So, V is what I'm trying to find. Determine the volume occupied by 0.582 moles. This is our N. We have a temperature here but it's in Celsius, so we have to add 273 to make it Kelvin. And then we have a pressure here, which is in mmHg, and that's going to tell us which R to choose. So now, which equation am I going to use? Well, because they have moles here, that means we're going to use this equation, PV equals nRT. So we have PV equals nRT. We're going to put our variables in now. The pressure is 614 mmHg. The volume is what I'm trying to find, so that's my X, equals my moles is 0.582. My R value is going to be the millimeters of mercury from our little reference chart. So if I look here, we find the R value that goes millimeters of mercury is 62.4. So this is 62.4. And then my temperature is 15 plus 273, which is 288. Now we can solve our calculation. Remember, don't start on this side. That's where the X is. We're going to start over here. 0.582 times 62.4 times 288. And then this is on the side of the X, so we're going to divide by that value. So I'll start with the right side, where I will multiply 0.582 times 62.4 times 288. And then I'm going to divide by 614. And that's going to give me 17.03. So X equals 17.03. Since it's volume, that means it's in liters. Our last sample problem. So again, we have to figure out which of these equations are we going to use. If we have moles in the problem, we'll use this. If we have grams in the problem, we'll use this. So as I read the problem, it says, how many grams? So grams is what I'm solving for. Are contained if we have a 5-liter flask, there's a volume. 20 degrees Celsius is a temperature. Don't forget, it's Celsius, so you have to add 273. And then finally, we have our pressure. Notice it's in millimeters of mercury, and that's how we know which R value we're going to choose from our chart. So because we have grams in this problem, we're going to use this one down here. But we're missing something, the molar mass. We're going to have to go to the periodic table, and we're going to have to add up the molar mass of Cl2, chlorine gas. Don't forget, it's a diatomic. So now I'm going to write out my equation. It's going to be mmPV equals GRT. When we go to the periodic table and add up the grams of Cl2, we get 70.9. We get this value from the periodic table right here. The mass of chlorine is 35.453. Multiply it times 2 because it has a subscript of 2, and that's how we get the molar mass is 70.9. So now I can plug in the values in my equation. The molar mass is 70.9 times the pressure is 650 times the volume is 5.0 liters equals the grams, X is what I'm trying to find. The R value is going to match this, millimeters of mercury. So I'm going to go look at my little chart, and there's millimeters of mercury, so 62.4 will be my R value. And then my temperature, I have to add 20 plus 273, which is going to get me 293. So now we can plug in our values in the calculator. Don't start on the right side because there's the X. We're going to start on this side. 70.9 times 650 times 5.0, and then we'll hit divided by 62.4 divided by 293. So I'm going to start on this side, 70.9 times 650 times 5.0, and now I'm going to hit divided by 62.4 divided by 293, and we get 12.6 as our final answer. So X equals 12.6 grams.